Hello everyone, my name is Johan Park from the CTR sales team, and I am honored to present CTR Group's aftermarket business today. CTR is a global leader in the automotive industry, providing high-quality parts for both OE and aftermarket sectors. In this presentation, I will introduce our company's vision, our strong manufacturing capabilities, our products, and our commitment to customer satisfaction. Let's begin with a brief introduction to CTR Group. This presentation will be handling our company's overview and the core drives of CTR. CTR Group has a rich history that began with our founder, Yi Jun Kang, who opened the Shilla Machinery Store in Busan. From these humble beginnings, we have grown into a global leader in mobility. Our growth has been driven by our commitment to innovation, particularly in the areas of automotive parts, digital transformation, and renewable energy. We prioritize mobility, which is at the heart of our business, along with safety, which is our core value. CTR Group has established a strong global presence, operating in 11 countries with 30 locations, including plants and offices. Our workforce consists of nearly 2,000 dedicated employees, all contributing to our mission of enhancing mobility through quality products. In terms of sales, we generated a total of $1.464 billion, with the AM and OEM automobile parts division being the largest contributor, accounting for 88% of our revenue. Our diverse business divisions generate significant sales, with the automobile parts sector being the largest contributor, showcasing our commitment to quality and innovation in the automotive industry. CTR operates through two primary business models: original equipment manufacturer, or OEM, and aftermarket, known as AM. In the OEM sector, we supply parts to global car manufacturers, ensuring they have the high-quality components needed for their vehicles. Meanwhile, our AM division focuses on selling branded parts directly to customers, allowing us to engage with distributors and service centers effectively. This dual approach not only strengthens our market presence, but also enhances our ability to meet diverse customers' needs in the automotive industry. At CTR Group, safety is not just a priority, it is the foundation of our operations and culture. We have integrated safety into our core values, which guide our daily operations and decision-making processes. By fostering a culture of responsibility and professionalism, we empower our team to work towards this shared vision of safety step by step. CTR is committed to a sustainable future through strong ESG practices, which focus on protecting the environment, being socially responsible, and maintaining transparent governance. By prioritizing safety in all our operations, we aim to fulfill our responsibility to both the planet and humanity, ensuring that our growth benefits everyone involved. CTR is dedicated to creating a safer world through continuous innovation. Our focus is on enhancing employee satisfaction, building customer trust, and promoting social progress, all of which are essential for ensuring safe mobility for everyone. Now, I'd like to introduce our aftermarket business in more detail. Let's begin with our four-wheel drive. Our focus in the four-wheel drive market is built on four key areas: sales, development, marketing, and production. By leveraging our extensive experience across 100 countries, we ensure that our sales strategies are grounded in local insights while maintaining global supply chain expertise. In development, we are committed to expanding our portfolio with over 2,000 new items each year, ensuring we meet the evolving needs of our customers. Our marketing efforts are tailored for the digital age, with a strong emphasis on B2B and B2C content, making us ready for e-commerce. Finally, our production capabilities are supported by a dedicated testing lab and advanced quality control processes, ensuring that we deliver only the best products to our customers. CTR Group has evolved from a small automotive parts store into a global leader in mobility, emphasizing innovation across various sectors. This growth has been fueled by our commitment to quality and our ability to adapt to market demands, ensuring we remain at the forefront of the automotive industry. In the aftermarket sector, CTR leverages its extensive global network and marketing capabilities to effectively reach and engage with over 700,000 customers across multiple regions. Our dedicated R&D center focuses on developing high-quality products that meet industry standards, while our impressive production capacity allows us to manufacture up to 2,000 new parts annually. CTR Aftermarket has established a robust global network that includes factories, sales offices, and warehouses strategically located around the world. This extensive presence allows us to effectively serve our 500 customers in over 100 countries. Our warehouses, located in 5 strategic locations, further enhance our ability to deliver products efficiently and meet the diverse needs of our customers. We keep our data reliable. We are a TechDoc data supplier certified as an A supplier who conforms to their standards with minimal errors and eager attentiveness. We, of course, have our own product catalog in operation, published both online and in print. The website was renewed in 2020 to provide a better user experience and more relevant product information according to the geographic locations of the users. This is where you can get the latest information as we release the list of new items on a monthly basis with any amendments. We are active in over 100 countries in the aftermarket business. To better connect with our diverse customer base, we currently run 37 online channels, available in 10 languages. Our social media following has surpassed 900,000. But we're not stopping there. Since establishing our marketing team and starting digital marketing efforts, CTR has consistently grown its global brand awareness, even during the pandemic. We'll continue to focus on using online channels strategically to engage with our customers and sustain our brand's growth. As we continue our discussion about CTR Aftermarket, it's essential to highlight our commitment to enhancing our e-commerce presence by improving our visibility on key platforms like Google and Amazon. This strategy not only boosts our media exposure, but also supports local dealers in their online sales efforts, ensuring we reach more customers effectively. CTR Aftermarket offers an extensive product range with over 9,600 SKUs. This diverse lineup features a significant focus on suspension, steering, and brake components, with nearly 6,000 suspension parts alone. Each year, we introduce more than 2,000 new SKUs to meet the diverse needs of global markets, ensuring that we stay ahead in product development and innovation. Additionally, our products are designed with compatibility in mind, allowing us to support up to 34 different vehicle makers. This flexibility not only broadens our market reach, but also ensures that our customers can find the right parts for their needs. CTR offers an extensive range of over 9,600 SKUs, primarily focusing on Korean and Japanese car models. We are also actively expanding our product offerings with plans to develop over 2,000 new SKUs each year for North American, European, and Chinese models. This strategic focus on key automotive components ensures that we can support our customers effectively and maintain a competitive edge in the aftermarket industry. CTR is also one of the pioneers in EV parts for both OE and AM businesses. Currently, we have 80% of suspension and steering parts for eco-friendly cars and keep investing to develop EV parts for the near future. CTR is currently recognized as a specialist in aftermarket steering and suspension parts, which highlights our expertise in this critical area of automotive components. We aim to expand our expertise and become a leading aftermarket specialist for chassis parts. This vision is driven by our commitment to quality and innovation, ensuring that we provide the best solutions for our customers. As we move forward, we will continue to invest in our capabilities to support this goal and deliver exceptional value to our partners. CTR has made significant strides in expanding its product portfolio, particularly focusing on Korean and Japanese vehicles. With a total of 6,600 SKUs dedicated to these markets, we will introduce 1,000 new SKUs in steering and suspension components, along with an additional 1,000 SKUs in other chassis components. This proactive approach ensures that we remain competitive and responsive to market demands, ultimately supporting our goal of delivering high-quality automotive parts that enhance safety and performance. We understand that maintaining a premium brand is essential for our success and the trust of our customers. To achieve this, we have established a rigorous quality assurance process that ensures all our products meet the highest standards. This involves multiple stages, including pre-assessment, product validation, and regular audits. By adhering to these structured verification stages, we not only strengthen our quality assurance, but also reinforce our commitment to delivering reliable and safe automotive parts to our customers. CTR aftermarket products are made by Korea. All the technology and quality elements are from Korea, by experienced workers with advanced equipment, through certified processes, and in collaboration with logistics experts. We operate 2 aftermarket factories, one in Korea and one in Vietnam. Korea currently accounts for 72% of our production, while Vietnam covers the remaining 28%. With production in Vietnam expected to gradually increase to meet growing demand, the Auto Valley in Korea, adjacent to our factory, is a dedicated supply chain complex. All the partners closely collaborate with us on production lead time, quality control, and cost innovation. This concludes our introduction to CTR Group's aftermarket business. We sincerely appreciate your time and attention today. At CTR, we are committed to delivering the highest quality products and exceptional service, and building long-lasting partnerships. Thank you very much, and I'd be happy to answer any questions you may have.
Hello everyone, welcome to CTR Tech Seminar. I'm AJ, in charge of a CTR test lab. As you know, CTR has been supplying ball joints to almost all global oil automakers for a long time. That means CTR ball joints are installed in vehicles almost everywhere in the world, In other words, we are very familiar with what the extreme environmental conditions are around the world. Based on that, I'd like to share our engineering information and knowledge with you here. CTR has so far conducted offline tech seminars focusing on general technical topics. However, from now on, we aim to hold both an online and offline seminars that focus on specific themes and share more detailed information on those subjects. This way, we can provide you with more in-depth technical insights on the areas you're most interested in. The first topic is boson separation. As you may know, if a boson fails or becomes separated, it can cause serious issues for the vehicle. That's why the automotive industry classified it as a safety part. Through this presentation, I hope your technical concerns regarding boson separation will be addressed. This is what I'm going to talk about this topic. First, let's take a quick look at what the boson is. Next, what happens if the boson separates, and what types of joint separation are there? What is the root cause of joint separation? Finally, I'd like to address the preliminary signs of joint separation. This picture is showing that the steering and suspension system of a vehicle. The red highlighted parts on the picture are 5 types of joint that CTR is supplying for steering and suspension of cars. They are control arm ball joint, inner tie rod, outer tie rod, a stabilizer link, and cross-axis ball joint. The products listed here all have different shapes and different names. However, all of them have a ball and bearing in common. Today's topic is a joint separation in a car. At this point, we need to be familiar with the names of each joint component. Those are cap, bearing, ball and stud, housing, sealing boot, and clampering. Before we jump into the next slide, please remember the names of these components. If a ball joint becomes separated from a car while it is in motion, it can lead to steering difficulties or loss of vehicle control, making it difficult to drive and potentially causing accidents. That's why ball joints are designated as safety parts in the automotive industry. Let's see what types of joint separation there are. In the automotive industry, it is generally assumed that there are 3 types of joint separation in cars. The video on the left is showing that ball stud is over travel in the operating tilting angle and is separate from housing. The middle one is a ball stud just straight pulled off from the housing. The right one is a ball stud broken by dynamic cyclic stress. In the next slide, we will have the opportunity to look at what evidence remains for the 3 failure modes respectively. This is showing the concept of how ball and stud is separate from housing due to over-travel failure. When the ball and stud is tilted and it begins to touch the housing, the leverage effect is in play. When examining parts where ball and stud is over-traveled and separate from the housing, we can see a permanent dent on the upper part of a housing, and the stud is bent, though not always. This is because the ball and stud generally has the strongest hardness among joint components. This illustrates the concept of how ball and stud is pulled straight off and separate from the housing. When examining parts where ball and stud has been pulled straight off, there is generally no dent on the upper part of the housing and no bending deformation of ball and stud. This is about how ball and stud break due to dynamic cyclic stress. When examining the general failure mode, there is no dent on the upper part of the housing and no bending deformation of ball and stud, but it is simply broken. This is a typical failure mode for dynamic cyclic stress fatigue. Now let's recap the previous failure modes. If you remember the differences among these failure modes, we may be able to tell at a glance what happened on them. The appearance sometimes gives us some idea of what type of separation has occurred on them. Now let's learn about the root causes of these separations. There are three main root causes of bolstered over travel. For bolster pull-off, there are two main root causes. When it comes to bolster breakage due to dynamic cyclic stress, there are three main root causes. Now let me talk about them in detail one by one in the next slide. This is one of the root causes of bolstered over travel, that is installing with the wrong part number. For example, a part number on the right side of vehicle is mounted on the left side, or vice versa. Installing different part numbers could cause problems in the maximum operating conditions of the suspension or steering system. That's because a permanent deformation of a stud begins to occur if it goes any further than blue john in the middle picture. Ball joints, outer tie rod, and stabilizer link may all have different part numbers on the left and right sides of vehicle. This problem mainly occurs in the stabilizer links. Therefore, please make sure if your vehicle's left and right part numbers are either different or the same before installing these parts. Here I want to talk about another root cause of ball stud over travel, that is over jounce, over rebound, oversteering. The table on the left shows designed over travel torque values and the actual test results for each joint type. Stabilizer links typically have lower torque values than ball joints and outer tie rods due to the smaller ball size. Therefore, the stabilizer link tend to have more problems with the ball stud over travel than other joints. This is one of the root causes of ball stud straight pulled-off, that is static overload. The graphs here show ball and stud pull-off requirements and the actual test results for each joint type in the global oil automaker database. For example, the graph in the top left is about the upper ball joint. X-axis on the graph represents ball sizes. Y-axis show pull-off force values. What's interesting here is that as the ball size increases, the pull-off requirements do not increase proportionally. In other words, there is no pull-off force increase in the actual car regardless of vehicle type or weight. The same goes for stabilizer link, cross-axis ball joint, and other outer tie rod. However, for inner tie rod and lower ball joint, as the vehicle becomes heavier, the stud pull-off load tends to increase proportionally. As a result, it can be predicted that stud pull-off separation due to overload is very unlikely to happen in a real vehicle. Here, I want to talk about another root cause of a ball stud pull-off, that is excessive wear of a bearing inside the joint. This video shows the start of the wear durability test of the joint. The end travel curve before durability test looks linear, as you can see, and it's considered as a good part. When the wear durability test of a good part is completed, the graph may show a slight curve like this. It's still okay. However, if 40 meters of water enter inside the joint, or the vehicle is driven beyond the designed mileage, the actual end travel curve will lie horizontally in the middle part of the graph, as shown in the picture. We technically call this free play that may produce noise or vibration in the car. If this condition remains unattended for a long time, the stud will eventually be pulled off or broken. In other words, this can happen if the driver has not had a chance to notice the various symptoms of the problem. This is one of the root causes of ball stud breakage, that is dynamic overload. In the automotive industry, joint suppliers conduct a kind of a test based on the assumption that a vehicle will be subject to a high load close to its yield point 1 to 100 times over its lifetime. When a heavy load is applied, as shown in the video on the left, the part experiences repeated elastic deformation. After the test is successfully completed, the actual end travel curve on the joint may show a slight bend in the middle part of the graph. However, no screws should be loosened and no parts should be broken. If the test fails, free play may occur, screw may loosen, or components may be broken. Here is another root cause of a ball stud broken, loose screws. If your vehicle's screw becomes loose, they will initially make noise or lose functionality, and it'll eventually cause parts to break. If a screw is tightened below the specified values, it may loosen while the vehicle is in motion. On the other hand, if a screw is tightened too strongly beyond its yield stress, it may also break. I'd like to provide a brief explanation of what happens. In general, tightening torque conditions are determined in the elastic region. However, if tightened beyond the elastic range, the screw may become permanently deformed or broken if the extra load is applied on the car in motion. That's why screws must be properly tightened according to instructions provided by the automakers. This is the last root cause of ball stud breakage, corrosion inside the joint. As previously explained regarding the excessive wear of bearing, the end travel curve should be linear at the beginning. However, if water entered the joint before or during the testing, steel component inside the joint will corrode and may produce noise or vibration in the car, like this. If this condition remains unattended for a long time, the stud eventually will be pulled off or broken. Now let's find out what preliminary signs appear before joint separation. These are preliminary signals before joint separation: noise, cylinder status, and the free play. The preliminary signs listed here are ones that drivers may recognize and notice on a regular basis. If a driver begins to hear noise from a vehicle's steering or suspension system, it must be a preliminary sign that there is a problem with the components. Here are some examples of a noise generated by joints. A squeaking noise here. In reality, this squeaking noise does not occur directly inside the joint. A slight vibration occurs at the joint first, and the vibration is amplified in the connected parts, resulting in noise. When you separate the joint from the vehicle and measure its friction torque, a good joint will look like this. But the noisy one will look like this. This spiky shape in the graph causes a vibration inside the joint, which leads to noise in connected parts. Now let's listen to another type of noise, a clunk noise from stabilizer links. This noise comes directly from inside the joint of a stabilizer link. When you separate the part from the vehicle and measure its actual end travel, good part will look like this. It's linear. However, the noisy part will look like this, a typical free play inside the joint. Let's listen to another noise that can be heard from inside the car when operating steering wheel. This is also caused by a vibration inside the joint, and the vibration amplified in the connected parts, resulting in noise. In any case, if you hear noise, this is a preliminary signal that you need to take actions. If you have a chance to take a look under the car, we might be able to gather more information. If the ceiling boot fails to prevent the foreign matters from entering, the lifespan of the joint will be drastically shortened. Here I will show you the typical failure mode of a ceiling boot classified in the automotive industry. Punctures occur due to a hard object or tool. These impacts can often be caused by objects bouncing off the road. However, sometimes punctures are created when installing the joint in the car. If a slit or crack in the ceiling boot occurs in a horizontal direction, it is most likely due to wear. As the ball and stud in the joint move repeatedly in the tilting direction, the ceiling boot wears out due to a contact with the rubber itself or contact with the balls and housing. If the ceiling boot is torn in a complex shape like this, there is a possibility that the ceiling boot design is poor. I will show you why it is a poor design in the next slide. The videos at the top show what good ceiling boots look like when installed in the mating part. The shape of good ceiling boots appears smooth after assembling into the mating part and seem to contain the right amount of air. And the videos at the bottom show what bad ceiling boots look like when installed in the mating part. Do you see the difference between good parts and bad parts? The bad ceiling boots become wrinkled and distorted after being assembled with the mating part. What would happen if I drove the car with these bad parts installed? Now let me show you what happens. Car makers in the automotive industry have their own environmental simulation test requirements. As the joint moves, the atmospheric temperature fluctuates between extremely low and high temperatures, and water mixed with mud and salt is periodically sprayed onto the joint. Here is an example of environmental simulation test results conducted by an automaker in North America. Good-shaped ceiling boots appear to have no visible abnormalities until the 17-day testing is completed. However, bad-shaped ceiling boots were found torn on the second day. In other words, if the ceiling boot is in poor shape when assembled, the life expectancy decreases to less than 1/10. Last but not least, this is about free play as a preliminary sign of a joint separation. If you can leave the vehicle using some kind of equipment, you can try shaking the wheels. If you feel a gap while you are shaking the wheel from side to side or up and down, it's going to be one of two things: free play inside the joint or loose screws. If you pick up the free play joint and conduct testing in the lab, the results are as follows. If the free play is not due to the fastener loosening, a gap must be created between the ball and bearing inside the joint. There will be almost no friction torque like this graph, showing typical free end play. This free play is likely to eventually develop into noise. On the other hand, good parts still have some friction torque values, and the end trough is linear or close to linear on the graph. Now let's recap what I talked about today. There are three kinds of joint separation: over-traveled, straight pulled off, broken by dynamic cyclic stress. We could estimate the root cause based on the type of joint separation. I talked about the existence of dent marks on the upper part of a housing and the bending of a stud. We should install the joint with the correct part number. We must check whether the left and right part numbers of vehicle are different before installation. Screws must be tightened to the correct values according to the instructions. They should not be over-tightened nor under-tightened. Abnormal ceiling boot shape should be corrected. Please take immediate action if the ceiling boot shape is found to be wrinkled or distorted on the car. Joint separation could be prevented through a periodic observation by monitoring noise, ceiling boot status, free play, and so on. You can avoid the worst-case scenario. This is all I have for this topic. Thank you. In this topic, I'll talk about CTR design strength, Last year, we've conducted a survey with customers worldwide to understand their technical interest. More than 100 customers participated in that survey, and we found that the most popular technical interest among customers is a comparison between CTR and its competitors. Due to time constraints, it's difficult to share the comparison data in detail here. However, I'd like to share the key reasons why there are differences between CTR and competitors, particularly those who don't have the experience of oil supply. There are several benefits and advantages to having oil supply experience. The first benefit is feedback from real vehicle testing and the field activities. The real vehicle testing and the field activities are conducted on such a large scale that it's challenging for a single component company in the aftermarket business. I mean, it costs an arm and a leg. However, the feedback from real vehicle testing and field activities enables practical improvements. This feedback provides a valuable opportunity to enhance ball joint design, manufacturing processes, and the quality management systems. The second benefit is access to detailed ball joint information from large scale of collaboration. As you know, a vehicle is made up of more than tens of thousands of components. The ball joint is just one of these parts. Understanding the information and requirement that a ball joint receives and the role it needs to play is something that automakers, Tier 1, Tier 2, and Tier 3 suppliers work on collaboratively. Through large-scale collaboration and research, the requirement for ball joint become highly precise, leaving no room for gaps. Certain insights can only be gained through a direct involvement in oil supply. It's very critical to understand every single word and every single requirement from A to Z, not only from the suspension system, but also from the vehicle itself. I don't think that this is something that a single component company can handle on its own in the aftermarket business. The third advantage is various global experiences. CTR has been supplying ball joints and working not just with one or two automakers, but with almost all global automakers worldwide. For example, GM, Ford, Chrysler, Tesla, and Lucid in North America, BMW, Daimler, Land Rover, Jaguar, Renault, Fiat, Peugeot, and others in Europe, Hyundai Motor, Kia Motor, KG Mobility, and Samsung in Korea, as well as some Japanese and Chinese automakers. CTR has encountered various environmental, road and driving conditions, and have accumulated a lot of data, knowledge, and experience from these. That allows us to create a kind of Bible for ball joint eventually. Without the experience of supplying oil automakers, it would be challenging for a single component company to handle all these tests on its own in the aftermarket business. According to the survey, the customer's second most popular technical interest is counterfeit parts. We don't have complete information about all counterfeit parts in the world, though we had a couple of chances to inspect them last year. Due to insufficient data, we cannot say all counterfeit parts have the same issues, but the ones we have investigated had some critical problems like this. The first issue is significant differences in critical dimensions. Some dimensions on the ball joint are very important. For example, taper dimensions on the ball stud and certain dimensions on the ball joint housing are in direct contact with the mating parts, such as the steering knuckle and the control arm. If these dimensions do not meet the specifications based on the original car's requirements, the ball joint's lifespan will dramatically fall short of expectations, potentially lasting only 1/20th to 1/10th of the intended warranty period. We found that some counterfeit part had incorrect taper dimensions on the ball stud, leading to a fatigue life that was 1/20th of the required durability. The second issue relates to the basic performance of the ball joint. As you know, the ball joint is a crucial component of the steering and suspension system. This system requires the ball joint to provide an appropriate operating angle. For example, if the system required a 28-degree tilting angle, but the ball joint only allows a 27 degrees, just 1 degree less, the bolster could repeatedly come into contact with the housing. Under repeated maximum driving conditions, this could lead to a permanent deformation in the short term or even breakage in the long term. This can result not only in a decline in vehicle performance, but also in serious safety accidents. But the problem is that most people don't know how many degrees of tilting angle its vehicle requires. The third issue is structure strength. The ball zone is installed between the steering knuckle and the suspension system. It is designed to transfer loads from the steering knuckle to the suspension system. However, if the ball zone does not have the sufficient structure strength to withstand the actual load from the knuckle, it can become permanently deformed, break, or even separate from the vehicle in a short period of time. We found that some counterfeit parts were made with the incorrect heat treatment steel components or even had the heat treatment removed. This means that these counterfeit parts have a significantly lower structure strength compared to the original parts, potentially compromising vehicle safety. The fourth issue is durability, such as abrasion wear durability, fatigue durability, sealing boot durability, and corrosion resistance. In fact, some counterfeit parts use the poor quality grease inside the ball zone, leading to a shorter lifespan. Additionally, the rough surface finish of ball accelerates the significant abrasion wear on the ball seat. Steel materials with high impurity content were used, resulting in a reduction in fatigue life. The sealing boot was made from incorrect rubber material or had a poor design, allowing contaminants to enter the joint in short period. Furthermore, some critical components had insufficient corrosion-resistant coatings, significantly reducing the expected lifespan of the ball joint. So what I just mentioned here, significant differences in critical dimensions, basic performance, structure strength, and the durability are very critical when selecting a ball joint, especially in terms of safety and durability. However, from a customer's perspective, it might be difficult to distinguish that at the time of purchase, whether or not the ball joint have these issues without the professional inspection. Recent counterfeit parts have reached a level where it is extremely difficult to distinguish them from genuine parts only based on appearance. For example, the color, shape, dimensions, and the packaging box are almost identical to CTR genuine parts, making it hard for even experts to identify them at a glance. Many of these counterfeit parts are so authentic looking that even experts cannot tell the difference at a glance. That's why we need to come up with effective countermeasures for this issue. So far, I've talked about the strength of a CTR design. To briefly summarize, the strength of a CTR design ultimately comes from our extensive experience gained through supplying to oil automakers worldwide. Even if you are not currently supplying ball joint to a particular oil automakers or specific car model, it's not an issue. We have a comprehensive knowledge in nearly all aspects, including design, testing, production, and quality management systems. For example, we clearly understand which design factors need to be reviewed in advance, what tests must be carried out, which materials should be used, how to manage suppliers, and what inspection processes are required. We also have a clear understanding of what global oil automakers expect, the responsibility that a ball joint supplier must fulfill, and the global trend in ball joint technology. Due to time constraints, I was only able to provide a brief overview of the topics covered in this session. However, in the next seminar, I will present more detailed data and test results comparing CTR products with competitors and counterfeit parts, which are topics we've shown the most technical interest in. Then you might be able to see detailed comparative data on CTR's advantages over competitors without oil experience and the specific potential issues of counterfeit parts. I'll be more than happy to see you soon. Thank you.